All right, let's take a look at this exercise, looking at compound and simple interest. We're going to look at it from the point of view, again, comparing linear and linear and exponential functions here. First thing we want to think about is for this idea of interest is, why does a bank pay you to store your money at the bank? There's not, maybe you don't know this because actually the interest rates in Japan are so low that it hardly seems like they're paying any money. But basically, the idea behind of why a bank pays you to store your money at the bank is they take your money and then they lend it out at a higher rate than they pay you, and they can make some money off of that. So that's why the banks want you to store your money at the bank, so they can use it to lend it out to other people and make some money off of your money. Let's say you had $1,000 and you invested it in a bank account that earned 5% simple annual interest. We want to know, how much would you have at the end of 1 year? Well, we're still gonna have the $1,000, plus we're gonna have an extra 5% of that, and 5% of 1,000 is $50. How do we find that? 5% as a decimal is 5/100ths. 5/100ths times 1,000 is 50, and so we're going to end up with $1,050. So how do we find out how much that you're going to have at the end of 2 years? Well, you gained $50 after 1 year. Nothing changes in the next year. The same thing is going to happen. You're going to earn another $50 off of that $1,000. And now you're going to have the $1,050 that you had at the end of the first year, plus another $50. That's going to give you $1,100. And I could do this for at the end of 5 years as well. I could keep adding $50 and $50, or I could simply start off with my $1,000. And I'm going to be multiplying that by 1, which is 100%. I know that I'm going to keep the 100% value. I'm not going to lose that. But I'm also, on top of that, I am going to add another 5% on there. But how many times am I going to add that 5% on there? I'm going to add it for 5 years. So I'm going to add it 5 times in there. And now I'm taking 100% and another 5%, but 5% 5 times. So I'm actually going to be adding 25% onto that. So I'm basically taking 125% of that $1,000, and that will give me $1,250. And there is actually a general formula for the amount of money one will have after investing P dollars. Why do they use P for what you start off with? It actually stands for the word principal, which is the money that you invest. At an interest rate, for interest rate, we don't use the letter I, we use the letter R for the rate, but we change it from a percent into a decimal when we put it into the formula. And for T years, we put the T in there. So the formula is A. Again, this is the amount that we end up with. P is what we start off with, times the 1, which is the 100%, plus the R, which is the interest rate as a decimal, times the T. And that formula will give us the answer. Notice that there are no exponents in this. And so this is not going to be an exponential function. How much money would you have after 10 years if you invested your $1,000 in a bank account that paid 6% simple interest? Go ahead and plug that into the equation and see what you get. So we end up with, when we take $1,000 at 6% simple interest over 10 years, we end up with $1,600. There's a problem here, though, because if you notice that back here, when I started off my 5th year, I actually had $1,200, but I'm only investing the original amount that I had in there, the $1,000 in there. And so I could be making more money if I were taking my money and reinvesting it and earning interest off of that interest that I had already earned. I know I'm making money off of my principal, my starting amount, but why can't I take the money that I make and put that into the account and earn interest on it as well? And that would no longer be simple interest. That is something called compound interest. In simple interest, the amount of money we're earning each year is not getting better. We got $50 the first year, $50 the second year, $50 the third, $50 the fourth, $50 the fifth. there's no progress being made here. I'm making $50 is great. I'm making that amount of money, but I have more money now. I should be able to make more money off of the fact that I have more money. So we have a problem here. Now, that's not a problem for banks. They don't want to pay people more money, but in order to be competitive, they really need to do that, because why would you put your money in a bank that wouldn't help you earn more? So they need to stay competitive. So what they do is they set up the accounts to automatically reinvest your interest into the account, so that you will not just be earning interest off of the initial investment, the principal, but also earning interest off of the interest that you already made. And they use a different formula for that. This is a formula called compound interest. And the amount that they have, again, is equal to the principal, what you start off with. We still start off with, we're going to make 100% plus some amount. And they're going to take the interest rate as a decimal, and they're going to divide it by this number n, which is the number of times that your money is being reinvested, or it's actually called compounded, the number of times it's compounded every year. So, for example, if you were compounding it monthly, then that means you're going to compound it 12 times per year. You're going to put the number 12 here. That number 12 also goes into the exponent, because you're going to be putting it 12 times per year times the number of years, which is still t here. Okay, so the answer to this question, if the interest is compounded monthly, then n is 12. Well, what if it's compounded weekly? What is n? Go ahead and answer questions 8 through 11, and then check your answers with mine. All right, so in this case here, we knew that n was 12 for monthly. There are 52 weeks in a year. There are 365 days in a year. And we have quarterly means that's 4 times a year, every 3 months. Semi-annually is twice a year, n equals 2. So you kind of need to know what these terms mean to be able to know what you're going to plug in for n in the formula here. So how much money would you have after 10 years if you invested your money in a bank account that paid 6% interest compounded quarterly? Okay, so we know our interest rate R, we know our time in years 10, we know it's compounded quarterly, so that should tell us what our n is. N is 4. Plug that into the formula and see how much money you would have at the end of 10 years. So after plugging everything into the formula, I start off with my $1,000, 6% interest rate. Quarterly means my n is 4, and 10 years means my t is 10. I get $1,814.02, which, interesting enough, back when I was doing simple interest, I was using the same money at the same interest rate here, and I got $1,600 after 10 years, $1,600. Now I have $1,814. So compounding interest is better for me if my bank does that. So I will probably switch to a bank that compounds interest, which pretty much all banks do now. They realize that people want to earn interest on their interest, not just on their principal. All right, so let's go ahead and try another one. What if we compound it monthly? How much of a difference is that going to make? Compounding it quarterly versus not at all ended up with another $214.02. Give a guess. What do you think? If you compound it every month, we expect, well, we're going to earn our interest more off of our interest more often. How much of a difference will it make? Let's go check that out. Interesting. I gained basically another $5.38. Not a whole lot of difference between compounding monthly and compounding quarterly. So the fact that I'm compounding at all 4 times a year makes a much bigger difference than whether I'm compounding, in fact, 3 times as often as I'm doing that. It doesn't make as much of a difference. Okay, so let's try, what do we would expect if we change it to compounded daily? Will it make a big difference? We're going to compound 300. The money that you earn at the end of the day will be reinvested right back into your account, compounded daily. How much of a difference will that make? Go ahead and figure that out. And sure enough, we get more money compounding it daily. Not that much more, though. Looking back here, a little bit less than $3 more by compounding it daily. It's nice to compound interest, but it doesn't make that much of a difference how often it's compounded. Just to make sure it is, you definitely want it to be compounded, though. That will make a big difference. All right, so looking at the formula for simple interest, which we had back here. Oops, where is it? Here we go. A equals to P times 1 plus RT. And comparing that to the compound interest one here, which is A equals P times 1 plus R over N to the NT, which one of these is multiplying by the same number over and over again? Well, let's just take a look at the last one we just did here. We multiplied by this number here, this same number here, 3,650 times. It's multiplying by the same. So the compound interest one is the one that's multiplying by the same number here, the same base here, over and over and over again. And which one has a variable of time as an exponent? There it is. There's time as an exponent. That is a compound interest one. So once again, when we have the variable in an exponent, that is actually considered an exponential function. So which one is exponential growth? Compound interest is. So the answer to all of these last three problems is compound interest. Interesting enough that simple interest is actually linear growth. We were growing by $50 every year in the first example that we did. That is linear. That's a linear growth. Compound interest is actually exponential growth, however, and you would much rather have your money growing at an exponential rate rather than at a linear rate, and you will be able to make more money that way. So big difference between linear growth and exponential growth, the difference between simple interest and compound interest.